Some earthquakes are very deadly, but what triggers them that makes them so deadly? So the most deadly earthquakes often occur along tectonic plate boundaries where immense stress builds up over time. When this stress is finally released, it can cause massive ground shaking. For example, the 2011 Tohoku earthquake in Japan was triggered by the Pacific plate subducting beneath the North American plate, releasing a colossal amount of energy. But how do tectonic plates interact to trigger such deadly earthquakes? Tectonic plates are massive slabs of the Earth's lithosphere that fit together like a jigsaw puzzle. They are constantly moving, albeit very slowly. When these plates grind against each other, collide, or pull apart, they can cause earthquakes. The boundaries where these interactions occur are known as fault lines. Let's take an example. The San Andreas Fault in California is a transform boundary where the Pacific plate and the North American plate slide past each other, often resulting in significant seismic activity. So, which areas should we be most concerned about? Certain regions are prone to catastrophic earthquakes. Should we be more concerned about specific fault lines? Regions along the Pacific Ring of Fire are particularly prone to catastrophic earthquakes. This horseshoe-shaped zone is home to about 75% of the world's active and dormant volcanoes and is a hotspot for seismic activity. Countries like Japan, Indonesia, and Chile frequently experience powerful earthquakes due to their location along this ring. Another notable fault line is the Himalayan frontal thrust, where the Indian plate collides with the Eurasian plate, causing significant seismic hazards in countries like Nepal and India. While the location is crucial, the aftermath of an earthquake can be even more deadly when it triggers tsunamis. Let's see how these massive waves contribute to the destruction. When an undersea earthquake displaces a large volume of water, it can generate a tsunami. These massive waves travel across the ocean at high speeds and can inundate coastal areas with little warning. The 2004 Indian Ocean earthquake and tsunami is a tragic example, where a magnitude 9.1 earthquake off the coast of Sumatra triggered a series of destructive tsunamis, resulting in over 230,000 deaths across multiple countries. Speaking of magnitudes, let's discuss what magnitude an earthquake typically needs to reach to become deadly. While there is no strict threshold, earthquakes with a magnitude of 7.0 or higher are generally considered capable of causing significant damage and loss of life, especially in densely populated areas. However, the impact also depends on other factors like the depth of the earthquake, the distance from the epicenter, and the local building infrastructure. Let's take an example from Haiti. The 2010 Haiti earthquake had a magnitude of 7.0, but resulted in catastrophic damage due to poor building standards and high population density. But why do some earthquakes cause more victims than others, even if they are of similar magnitude? Several factors influence the casualty rate of an earthquake. The time of day can be crucial. Earthquakes that strike at night can catch people off guard while they are sleeping. The quality of construction also plays a significant role. Buildings that are not designed to withstand seismic forces are more likely to collapse. Additionally, the preparedness and response of local authorities can make a big difference. For instance, Japan's stringent building codes and early warning systems have helped mitigate the impact of many earthquakes. Now, if you look at some of the most deadly earthquakes, you'll notice a pattern of immense destruction and loss of life. But what makes these particular earthquakes stand out in history? Some of the most deadly earthquakes in history include the 1556 Shanxi earthquake in China, which killed an estimated 830,000 people, and the 1976 Tangshan earthquake, also in China, which resulted in around 242,000 deaths. These events highlighted the importance of earthquake-resistant construction and the need for effective disaster response plans. More recently, the 2010 Haiti earthquake underscored the devastating impact of poor infrastructure and the critical need for international aid and support in the aftermath of such disasters. Earthquakes are terrifying natural disasters that have shaped history, from the ancient world to modern times. Now, this whole video will cost you 1 subscribe, and if you want to learn quantum physics in just 4 minutes, then click on this video.